So thank you everybody for coming after lunch for this session, and I'm going to speak about hiding your implementation details and why it is not so easy, not so simple as we may think. So let's begin. I will let you enjoy the picture a bit more, but okay. A few words about myself. I'm a lecturer at the Academic College of Tel-Aviv-Yaffo and Tel-Aviv University. I'm also a member of the Israeli ISO C++ national body. I'm a co-organizer of the core CPP conference and meetup group. We just opened the call for speakers. Speak with me about that. We really wish new speakers and speakers that we had in the past to join the conference in November. I'm also a trainer and advisor, C++, but not only, and that was about myself. Hiding your implementation details. Let's start with why. I think we all know the answers, but just to build up the motivation. So first, encapsulation. We all know that when we speak about encapsulation, encapsulation brings some protection on object integrity. We know that we have object invariant state valid by not exposing something that will make it invalid. It is easier to use because users see only what they actually need. It improves maintainability. Internal changes do not affect the external code. And it is easier to debug because you can easily see what actually happens inside the class. It also serves for decoupling, another value that we strive for. Because once we hide things, then it reduces dependency. Usually, you are not dependent on something that maybe you use internally, but you do not expose the use of this resource or other class. And again, it facilitates changes, enhances reusability, again, by you do not rely on something. Maybe you use it internally, but you do not expose this dependency. And once you do not expose dependencies, then you gain reusability because it is easier to reuse your class without grabbing a long tail of dependencies. And it improves testability, as already discussed yesterday by Bloomberg talk that I will refer to also later. So why is it not so simple? And it's not only me saying that. I mean, maybe some of you know the other guy who says that also, David Parnass, who is maybe, I think, the first one, Professor David Parnass, who raised the term or the idea, the concept of information hiding. By the way, he also had a paper on software aging, referring to the programming aging. We both age together. But I'm going to speak about the first two, modularization and information hiding. And he said that information hiding is harder than it looks. Now, in one of his presentations, he listed 7 reasons. It's a very good presentation. There is a link, and you can follow that later. I will summarize mostly these 7 reasons into my 4 reasons of why it is a bit complicated to hide your internal details. So first, because we are lazy. And when I say lazy, not in a bad term, I mean because we have a lot to do. And in some cases, we think that, yeah, we can maybe improve that later. But improving things later, in many cases, are either undoable or very costly. I mean, doing things right on the first time usually is much cheaper. So yeah, we may think, let's cut the fancy design. No need for that, but there is a need for that, and I will try to convince you. Take a look at this one. What do you say? Someone was exposing the details, was not hiding information, the internal information details. Stud pair, has first and second. First and second are data members. They are in the public. What do you say about that? Does it bother you, or you say, no, it's okay? it bothers me, and I will explain you why. Okay? I will try to convince you that even for pair, it shouldn't be two public data members. We'll discuss that. In some cases, we do not follow the rules of hiding implementation details because we do not realize that we actually expose private details. I mean, this API exposes some internal information. What is the internal information being exposed? That there is some kind of a map inside the class, probably, holding strings pointing to an int, string mapping to an int. I mean, and if I want later to change it to an unordered map, can I? Quite difficult, because you return a reference. I mean, I cannot even copy something and then return something else. I mean, something is being exposed here that will be quite hard to change later. And in some cases, it's hard to hide our implementation details because of technical reasons, technical constraints. Like in this example, let's assume that we have a factory method called create, and the create method wants to create a foo by using make unique. So we return a unique PTR, but make unique needs accessibility to the constructor. So the constructor cannot be private. It doesn't really work even if you go with friend. And we need some method to hide the constructor, or at least make it, even if not private, almost as private, technically private, but it is not so easy. I mean, we'll discuss it. Okay, so the constructor here is public, and we do want to enforce the usage of the factory. We don't want you to use the constructor directly. I mean, this is why we have the create function. We want you to use the create function. But once the constructor is in the public, someone would call it, and we don't want it to happen. How can we do that? Well, maybe put it in the private. Well, it will not compile. We have to solve it. And in some cases, we don't go for solutions. We just say, this is how it works. Well, better look for solutions, because eventually, we do want information hiding, encapsulation, decoupling. And in this case, enforcing the actual API that we want to provide. And in some cases, we do not follow the hiding rules because we believe that there are trade-offs, that we do want to provide some information, and thus, because we do want to provide information, we expose something. And then the question is, what is the actual information that we want to expose to the user? In some cases, the information is related to something that the user can use for performance-wise. I mean, I do want the user to know that my return container is random access, accessible by index. Can I expose it? How? Should I say it is a vector? No, maybe it is too much information. So in some cases, we do want to expose some information, but then the question is, how much? So our goal in this talk is to investigate code examples and cases, see how we expose implementation details, understand why it is not the best design, and propose better design. Let's start. So let's start with std pair. What's the problem? I mean, I would say data members should be private, but in this case, I don't know. Why should we bother? Why it's a bit annoying that first and second are public data members. I would say it is a language accident, but why? Because it might be that you want to use your own pair type and send it to a function that wants to accommodate anything that behaves like a pair. Let's assume that you want to create a generic function that handles something that behaves like a pair. Can you give me examples of other things that are not pair but behave like a pair? A tuple of 2, for example. My own class that behaves like a pair. Now, in order to create my own class that behaves like a pair, I should have, I will be used as a pair. I want to create my own pair for some reason, and I want to send it to a function that takes something that behaves like a pair, a templated argument. Okay? So I should expose first and second. The thing is that my pair, I want to create a lazy pair. I want to create a pair that I initialize the first, and the second is being calculated. Let's assume a square pair. I initialize the first, and the second is a square of the first number. Now, I don't want to calculate second unless it is being actually called, unless it is retrieved. I mean, it might be that the user will only need first. And it is quite problematic with data members. I mean, it is doable. How can you still achieve lazy evaluation on second, even though first and second should be members? Something like, I want to create my own pair, square pair. You see it down below. I initialize it with 7. I don't want to calculate second. And yes, I can do that, but I would prefer pair. If pair would come with first and second, which are functions, it would be much easier. I can still support lazy evaluation. How can I do that? Second might be here. An optional, then the behavior would be that I should get it and then deref it or something. So second might be a proxy class with the casting operator to the actual value that I need. But proxy classes are, well, leaky abstractions in a way. I will end up like a vector of booleans. I mean, I can do that. But my first choice would have been if first and second would be just functions. It would be much easier to create generic code that says, yeah, I can implement first and second with my own logic and add breakpoints and do some logic inside. Once first and second are data members, in a way, it dictates not only the usage of stud pair, but the usage of any class that wants to mimic, to behave like stud pair. A problem. We should avoid that by always making data members private. That's easy. Structs in general. I mean, in many cases, we just use a struct, or we just say, OK, this data member can be in the public. Why? I don't know, maybe because it's const. Or maybe because, that's just, a struct of 2 types. Even I'm using safe types. And I write to it. I'll pass it to you. You read from it. Why should I bother with all these getters and setters? What's the problem? Things may change. Or we may want another type of order. This is an order for a stock market and for exchange. And I'm passing an order with price and quantity. And then maybe at a certain point of time, I want to support a generic order. And I do have another order. This should have been the way that I use it. But without that, creating a timed order that has a price which depends on the time. Maybe the user wants the price to depend on the actual hour. Okay? So we may have a timed order. Now, once you work with an order and you want your generic API to work with this one, it would be quite hard to accommodate something that actually needs the functions. Now this one assumes that price is a price. And in our case, with a timed order, a price depends on something else. So I do need a function. And if I started with, order is simple, and now I have functions and processes that work with orders, it would be quite hard to work with other type of orders which their price or their quantity is being computed. So I would say, again, start with private members and use functions. But if it is a const member, I mean, let's assume that we just have a const member. I just initialize it when the object is created, born, and then no one would change it, modify it. So why should I bother creating a getter? There wouldn't be any setter. Let's take an example. Let's assume that I have a person. In person, I have a long ID. I mean, you're born, you get ID. Why should I put the ID in the private and provide an accessor and a getter. Why should I? Maybe because requirements change. And at a certain point of time, somebody comes in and says, you know what, ID is not a long, we actually need a type for ID, so let's go with type safety. And ID should be your social security number, and if you do not have a social security number, it should be your passport number. OK, so I will change it to ID as a class, still hold it in the public section. It is still constant. But then somebody comes in and says, but again, you know that passport may be reissued, and you'll get a new passport number. And you have to hold the history of the previous passport and the new one. Oh, that's a total new thing. I need to, and then it cannot be const because the ID changes something inside, and still, I mean, it is still myself. I mean, quality will see that, oh, the previous passport has the same number, you have a new passport. There is some logic inside. And it is not const anymore. Things tend to change. And when things tend to change, and they were exposed, it would be much harder to change them. The refactoring would be much more costly than just saying, you know what, I should have started with ID in the private section. And then, yeah, it might be that I need to modify the functions to accommodate the changes, but it might be that most of the changes can be treated, handled inside the class itself without any disturbance for the external usage, for external users. We should start with that one. API. So when we speak about APIs, and I include here internal APIs, not only external APIs. I mean anything that I expose to, even to myself. Then we need to think about Io's law. Anything that is being exposed would be used in a way, even if not designed, planned to be used in that way. So we should be quite careful. I mean, we do want to expose API that would meet the needs, but not more than that. And be quite careful with that. Io's law, software engineering at Google, says that with a sufficient number of users of an API, it doesn't matter what you promise in the contract or what you write on documentation. All observable behaviors of your system will be dependent on by somebody. And then it would be quite hard to change the behavior that was exposed in a way. So studies show that applications tend to use a small part of the API. Unused API is much more bug prone. Why? Because it is unused. Which means that even if it is tested in the lab, it is not actually used in production. And once you will say, oh, next week it will be used in production. We just saw what happens. So when there are too many options, this is another story. When you expose too many options on your API, a wrong option would be selected at some point. I mean, too many overloads. Why do you need all those overloads? Oh, because some of the users wanted that and others wanted that. So we created all of them. Somebody will use the wrong overload. Less options means also less required tests. So when we speak about API, we should be lean and mean. I mean, don't take it to your personal life, please. In your personal life, try to be nice and kind. But in your professional life, when being asked for, can I have another entry to this class? Can I have this additional API? The answer should be no. Yes, a simple no. Because eventually, when you say yes, you hurt yourself, and you actually hurt the user. Because you say yes also to the other team, which adds another function that the other user doesn't need, but eventually would accidentally use. Too many API points. The differences are subtle. I don't know, I used the wrong one. Why? I don't know. The differences are a bit misleading. OK, so just don't add them. I mean, can I have this function not with 4 arguments, with 3, because the 4th one, can you give me the default? No, send the 4th. You can even solve it on your side with a, I don't know, usually a facade. Create a facade on your side. On the other team side, add the additional APIs that you want to support. I only provide these. So be lean and mean. Keep your API short and concise. Limit your API to what should actually be used. Do not expose too much of your design. Different usages may get different views, and we will discuss the last third point. Yesterday, we had a few great sessions that touch some of these points. So I want to reflect to these. Having a concise API reduces the programmer's cognitive load. I mean, it's short. It's concise. It's not big and messy. And that's important. Follow David Zalewski, great talk on cognitive load and experienced and novice programmers. It's important. Let's go to decommission. Again, a talk yesterday by Peter. If you expose less things, then you have later on less things to decommission, to remove, because usually if something is not used, at a certain point you want to remove it. Don't expose it to begin with. By the way, how can you achieve that? How can you know what should be exposed? Try to work, especially in your design, partially in your implementation, top to bottom and not bottom up. When you go top to bottom, you start with what is actually needed and not what can we create and maybe would be used. No, let's see what is actually being required. And we keep the O in solid. And again, referring to Mike's very good talk on architecture. And keeping solid is not just because we like this acronym. It's because it accommodates modification. It is easier to modify your code if you go with the open-close approach or idea. So we actually want to keep our APIs open for generic use, but closed for misuse, for anything that we didn't plan for. And it also makes our code easier to test. And again, I refer to a talk given yesterday, great talk by the Bloomberg guys on testability and API design. You should follow these talks. All are referring to the same idea of implementation hiding. But it is context specific, and that is an important point to note. It is context specific because the interface that we provide shall be as narrow as possible, but something that is reasonably exposed in a certain context might be still private in another context. I will try to explain that. I mean, it's an important point that I would want to delve into. Should we expose different behavior to different contexts? I would say yes. Can we identify the different context? Quite hard, but we can. Let me see. Yeah, the mouse went off. So Tony Van Erde, I just saw him, I think yesterday. I'm not sure that today, but he is giving the closing keynote. If your flight departs before, change the flight. You should be on Tony Van Erde's keynote because he's a great speaker. And I'm taking a short koan. A koan is a story with a moral, a short story with a moral, okay, from Tony Van Erde's talks. This version is from his Twitter account, from X, when it was still called Twitter. So let's go with the koan. The same koan appeared also, I think, in CppNorth and in CppCon maybe. You'll find it in Tony Van Erde's talks. If you haven't heard any talk by Tony Van Erde, you should. A master is going down the street with his dog. And either intentionally or just by accident, he walks near his student's house. So the student is saying, "Master, I'm honored by your visit." I don't know if the master was actually visiting him, but he was there. "I was out walking my dog." And then the master notices that the student is working on a code assignment or coding something. The master is asking, your function, why does it take big common struct instead of just x and y? So the student answers, BCS is both because big common struct is where we keep x and y master. Bark, the dog just barks. He is hungry, the master says. Shall I prepare him food? The student is asking. No, just open the fridge. Let him take what he wants. That's it. Did you get it? Yeah, something, I mean, someone would feel a bit uncomfortable here. So I continue to Act 2. I see that there is a note over there. Yes?
So you're arguing against the approach was passing config structs for all.
I still do not argue. I still with Koan. Let me argue first, and then we'll take notes maybe. Maybe we'll delay to the end, but I do want to discuss. But first, let me give the argument. So Act 2, I add to that. The student is a bit concerned. So the student is saying, master, though I trust your dog completely, I still got a concern. So the master is asking, what's your concern? The fridge engine is in the private. I mean, nothing should go wrong. You have private members. The engine is in the private. The fridge would not be hurt. But the student is not worried about the engine. The student is worried about his own dinner, or I don't know, the mess that is going to happen there. And then the question is, why are we going to meet this mess? Because the API was not planned for the dog. And it is context specific. Something may be required to be public for one usage. I mean, the student should be able to access his own fridge. The master's dog shouldn't. And yet, in many cases, we do not have a reason to expose public behavior or public details to others. Do we do that? Occasionally, not always. And it is context specific, which means that something may be required to be public and private to others, because if they don't need it, the best thing is not to give it at all. Because if you do give it, they will use it. And if they will use it, they will misuse it. And you should trust no one. So, and having things in the private doesn't really help. So passing args. Exposing only what's needed. How can we do that? I mean, what are our tools? I mean, the master proposed maybe you should pass x and y, which I can understand. I mean, x and y are the arguments that the function actually needs. And I can actually also understand the student. Because usually it starts with x and y, and then later on you understand that, oh, I also need z, and I also need another thing. And eventually, you just take all the internal values, data from your struct, and take it out, extract it into arguments, which then will also change the API. And if I want to have a stable API, so maybe I do want to get something that will accommodate anything that I will need in the future. What can be the thing that can accommodate anything that can be required in the future, but actually will not let me use anything that should not be used? It shouldn't be the original actual struct, because with the original actual struct, the dog is in the fridge. It can be something that represents the fridge. It doesn't have to be x and y. I mean, if I know that it is only x and y, and I do not foresee any change, I will go with x and y. But if I do foresee a change, if I say, no, today it's in x and y, tomorrow I will need something additional, so maybe I should create something that holds both x and y, call it whatever, arguments for something, and add anything else which is needed later on, but only what is needed. Any other approach that you can think of? Maybe an interface. I can send an interface, which means that I will actually send the fridge or the thing, the entire thing. But the other side will see another representation, which also, this is also fine in a way. Another approach might be to create a wrapper class that does not get the values, but get a reference to what you want to hide. You can think of that as private inheritance or composition, and then exposes what I actually want to expose. And another approach might be we can think about concepts, C+20 concepts. Maybe C+20 concepts can help here in a way. So language tools that may assist us here in this challenge would include value semantics, send values. By the way, by sending values and not references or sharing data, you know that maybe you've heard Dave Abrams, Sean Parent, that sharing is not caring in APIs. Because once you share, you start locking, and you start worrying about data races. And data races will arrive unless you are actually locking. So sharing is not the best thing. And if you can avoid sharing data, I will pass you the data that you need, but as a copy, as a value. You actually need the value. Then you will calculate something and return a result. And then maybe the entire API is stateless, which is usually easier to maintain than a stateful API or something that actually works on the same data. So if I can go with value semantics, either by sending the actual values or by wrapping them, again, as values, this would be my first choice. As long as, yeah, it's OK that you actually send values. It's not too expensive. I mean, in some cases, you say, no, it's a bit expensive to copy them. OK, we'll think about other options. And in some cases, you actually want to see the latest update on this variable, and the variable might be updated while you hold it. So you want to lock only when you actually want to retrieve the value. Might be. OK, maybe I do want a view on the actual thing. But if you do not need the view on the actual thing, and it is not costly, just pass values, either as themselves or wrapped by something. Then the other option is interface. Instead of sending you the actual, I will send you the actual thing, but the API will say that you get some higher interface that actually exposes only the things that I allow you to use. Now, what the user can still do? I mean, criminal users would do that in some cases. Downcast. But I will see the downcast. If somebody does downcast in their code, I will see it in code review. And I will ask, why are you doing this downcast? Oh, because I need this function that is not on the interface. What do you actually said now? No, this is not something that we want to do. We should use the interface. We should not assume something, because later on something would change, and this downcast will not work. This is not generic programming. So once I pass the interface in a way, the API is enforcing using what I actually want to expose and nothing else. Yes, you can bypass that, but you should not. The pimple idiom is related to that, private implementation. I may have pointer to the actual implementation. You get the header, you get the type, but the actual implementation is hidden. You also achieve hiding the actual details for the build, which is also a good idea. A wrapper class as a view. So in some cases, you cannot use interface. Can you have an example why interface would not be possible? I want to pass you something. I want you to use only these options, these functions, not the others on that type. But I cannot create an interface that you implement, because I'm passing something that I don't own, a class that I didn't write, an external class. So I cannot create an interface for this thing, OK? But I can still wrap it. I can still send you a view to the thing. And I also want to discuss C+20 concepts, because in a way, it might be, there is a question mark, it might be that they can assist in at least documenting, not so maybe as enforcing the actual API that I want you to use. So let's take an exercise. Did you bring laptops? No, I'll do it on the slides. Don't worry. I want to implement a const map with mutable values, and I will explain. At a certain point, I have a map, okay? And I want to pass the map to the other side, and the other side needs, or at least there is a need, it might be that the other side would have to override values on that map. But the other side shouldn't alter the map, shouldn't add values, add entries, or remove entries. So I cannot send a const reference, because then you cannot actually change the values. But I also don't want you to send the map as is, because once I send the map as is, somebody will add entries or remove entries. And I don't want to allow that. Somebody might be me. I had bugs that I created for myself, and later on, oh, why did I add that on the API? I used it and I shouldn't. So how can we create that? Let's use the options that we have before. I will not use all, but I will start with the last one. Let's discuss C++ concepts. So for concepts, if I want to go with a concept approach, I will use the Mender, following Rudyard from yesterday. He also had a Mender for concepts in his talk, and I will have mine. And this is going to be a short talk on concepts, unrelated to information hiding, but then we'll use concepts for information hiding, maybe, if it would work. So let's have a short Mender on concepts. How many of you are using concepts today in their code? How many of you are familiar with how C++ concepts work? OK, half the room. I think that it should be valuable. So what's a concept? A concept is a constraint on a template argument evaluated to a Boolean value at compile time, which may be used for overload resolution or to cancel a function or a class. Not use this thing because I do not obey to the required concept. It's a much more elegant and simple substitute for Sphinx. A first example. Let's assume that I want two print functions, one that gets iterable and iterates over all values, and another one that gets something that is not iterable and just prints it. What do you say about this code? Would it work? I'm sending a vector to which of the functions the vector would go. Yeah, it's ambiguity. There isn't any difference between no difference between the functions. The only difference is the name of the template argument. I mean, this is not a way to distinguish between two template functions. So we need to do something like Sphinx with some enable if asking, are you iterable? And for iterable, maybe we can create our own isIterable type trait, which checks whether you have iterator that you can loop with. Yeah, we can do that. And then we distinguish between the two functions by Sphinx. But we can do that with concepts. And there is a nice concept that actually, in a way, checks that you are iterable. Do you know what is the name of this concept? Range. A range is something that you can iterate over. So I can say, oh, C++ came with ranges. So I can ask, are you actually iterable by requiring you to be of type range? And I can do that with a requires keyword on the template argument T. This is one option. Using here predefined something that already is in the language, range concept that comes from std ranges. Range is a concept. And range is checking T. Does T obey to the requirements of the range concept? I can do that with another syntax. I would say maybe nicer, saying that T should be a range. And then T is like being injected into range, and I check whether T is actually a range. And if it is not, like in Sphinx, the function would not be in the overloading set. I mean, it will not be harder, or it will not be compilation, or it just will not be picked by the compiler. And then I will go to the other one. And another option is to use auto argument and say, OK, I'm getting an auto, which is a template starting with C++. and then I narrow the template argument to be range. OK, that's nice. Can we create our own concept? Sure, we can. And the classical example is a meowable. So let's have a meowable concept requiring for a t that t has a meow function. By the way, in this example, specifically, the meow function should be const. Should have a const modifier. Why? Because after the requires, I say that let's assume that I get a t, and let's assume that this t is const, and let's assume that I have an object of type const t, call it lowercase t, then I can call meow on this t. Now, it is an unevaluated context. I mean, when the concept is being checked at compile time, the function meow is not being called. The compiler only checks that the function meow can be called. So if you do have a meow, a const function meow, then you would meow. You can meow. And then I can have a function do meow that actually wants to get meowable and calls meow on this thing. The requires keyword, I don't know if you noticed, I add the requires keyword here. Do you see it here on the concept? And I also add the requires here. The requires here on the template argument, on the function, and the requires here on the concept are not the same requires. There are two different keywords I mean, it's the same keyword for two different usages. So the require keyword is being used as a require clause, which constrains a template function or a template class, and also as a requires expression that creates a concept that allows to require something for the concept. So the requires clause that actually constrains a function or a class, a template function or a template class, has all these possible options. After the requires, you can have a const x per bool, like true or false, or something a bit nicer, like checking something, but something that can be checked at compile time. It can be a bool constant expression, a bool constant expression based on a type trait, a concept, which actually a concept is being evaluated at compile time to a Boolean. An ad hoc concept. You can actually create a concept and require a concept without a name, an ad hoc, an anonymous concept, and then require the function to obey to this concept. And then you use the requires twice, once to say that I require something, and then to say, and this is the concept, and it doesn't have a name, but to define the concept, I need the requires keyword, and then it would come to be requires, and then what to require. And then a conjunction of any of the above. I will not show examples because this is only a Mender and not a full talk on that. The requires expression for a concept looks like that. It may take an argument. It may not if you do not need an argument. I mean, T, capital T, is known. The idea of getting lowercase t as type T saves us the need for, inside the concept, to use decal val. I want to say something not about the type T, but about an object of type T. Oh, so you have to create an object of type T. Yeah, I can do that with decal val, but I save the need by saying, OK, let's assume that I get a T, something of type T. Let's call it lowercase t. Then I can require something like that t as a full function. So the things that you can require in the on the concept, the constraints, can be a bool constant expression. I don't need the requires keyword. I can just say concept fooable is, and then put a constant expression, like true. Everything is true. Or some bool constant expression that checks something. Or requires, that we will see in the next slide. So I can require some requirements, and then there will come a curly body, maybe argument list, with these options. And the options are unevaluated expressions that just need to be valid. I mean, the example is 1, t : foo, which means that t must have, OK, I require something inside the concept. I require that t : foo is valid, which means that t needs a static function called foo that doesn't get arguments or is allowed to be called without arguments. Then the other one requires t : size equals 2. The requires keyword here on the second line is required. Why? Because if I just write t : size equals 2, then the expression is being checked whether it is valid, not whether it is true. So once you have a size static const expr field in T, even if it is not 2, if you omit the requires keyword, then it is valid. Maybe it is false, but you didn't ask if it is true or false. You just said that it should be valid. And it would compile. And it would say, OK, even if it is not 2. So you need the requires keyword saying, oh, and I required it to be true. Yeah, don't omit that. The other one, the next one, is to inject a return value and check a concept on it. So let's assume I call bar. In this case, bar is, again, a static function. I want to check that the type of the return value from bar is int. So I'm using another concept. Same as is a concept. Same as a concept gets 2 arguments. The first argument is being injected from the curly brackets, from the call to bar. And again, it is unevaluated context. What is the type of the return value? OK, I want to use it, and I want to check that it is int. And the last one is I need an internal type in T called inner type. And without the type name, it will just not compile, I think. So this is a crash course on concepts. The params themselves, if I have a template printable T. So printable is a concept that takes 1 argument, T, and checks that T is printable. Once I put the printable inside the angle brackets of the template, then T is being injected into printable. So T is being checked to obey to printable. Same thing in print2. The type of the argument, the auto, is being injected. On the other end, when I use it in other contexts, like in the requires, I need to provide T. There are concepts with more than 1 param. For example, I have here a concept called dereferenceable. How can I know that you are dereferenceable? If I can. Dereference you, which is a bit more generic than just is pointer. Who can be dereferenceable and is not a pointer? Iterator, any object that does a dereference operator. An optional is another option. Dereferenceable 2 gets another second argument, which not only what I check, but I want to check it against something. So T is the type that I check. Value type is the thing that I want to check it against. So inside, you are dereferenceable 2 if you are dereferenceable. And also, if I remove cvref of decal type of the return value of what is returned from the dereferencing, then it should be the value type. So I used here another additional. I will skip the exercises and go to our exercise. OK, back. So we have an exercise. Are you ready? Now you know how to implement it. I want to implement a concept that will, in a way, enforce the contract of you can change the values, but you cannot alter, modify the map itself. OK, let's have a first attempt. Let's assume that we have a concept. You remember, we just had it on an autoref argument. Let's call the concept const dict mutable vals. Let's assume that there is kind of a concept like that. And inside, the concept allows that. What do you say about this approach? Oh, I don't allow you to add any additional entries, but I do allow you to override entries. What do you say about this implementation of foo? No, that's not good, because I'm using the index operator can add new entries. OK, so let's go with that one. The concept will require only the relevant API to allow what I have here in the function, which is I want you to check if the value, if the key is there. And if the key is there, I want to override the value with 3. OK? Now, if I have a concept, sorry, contract is something else. I don't want to confuse them. If I have a concept, and the concept would require these options to be on the type, would it be something that helps us in this case? So the answer is, in a way, it's better than just documentation. It says, OK, you should assume that you get something that allows you to do what the concept actually allows you. And that's the concept, by the way. The concept says, You are a const dict mut vals if you are T, and I extract from T the key type, and you have an iterator and a key type and a pep type, and I can call find, and find can check its equality or inequality to end. Eventually, if I have that, most probably I can use what I see in the previous slide. And that these requirements, in a way, do not open the ability for adding, at least it seems so, adding new values or erasing values. The issue is that when you use concept, the concept is being enforced, being checked on the caller side, but not on the user side. I mean, on the user side, it is being checked that you obey to the concept, but it is not checked that you do not use anything that is beyond the concept. It's not like an interface that you cannot use anything that is not on the interface. You can use anything. Duck typing, if it is there, it will compile. How can I still make sure that you will not use anything that I didn't want you to use? I mean, in a way, the API says, do not assume something that is not on what I said to you, but then I am slower. You will just check. It compiles. I use something. It works. It doesn't even require any downcast. So concepts are not such a strong enforcement. And still, maybe I can add something that would be able to enforce it maybe a bit better. Not const. Something that usually we tend to do with coding. We are not done if we do not do that. A test. We can have a test that sends to the function something which exposes, which has only the things that we actually want to provide. Now, the function would not compile if it is using anything that is not on the concept. But it requires another thing. It requires, oh, and I also added a test calling the function with something that obeys very strictly to the concept that I wanted to use. I can do that. We can do that. We can add such a test, but it's an additional effort. Okay? So the concept by itself is a way to convey the information. This is what I expect. I mean, it is better than sending you the actual thing. If I send you a map, I can assure you that someone would use the map wrongly, not the way that you wanted. If I pass you auto, you can do anything. You say it's auto. Let's see what it is. If I say that, that's in a way, conveying information better than documentation, saying this is what I expect you to use. Is it being enforced? No. Can you enforce it? Maybe by adding a test. OK, let's have another approach, a wrapper approach. So with a wrapper approach, we can do the following. We can create a class. Let's call the class const dict mutable values. And this class is a templated class because we actually want the class to be able to handle any type of associative container. You will get associative container, you will hold it by reference, and you will expose only the things that you allow me to use. Like, let's assume that the function is a sign. I expose you a function called a sign. Can you do anything else with const dict mutable values? No, you can only call the sign function. How can you do that? By creating a class, const dict mutable values, that actually holds the reference to the associative container. I'm using here, again, another reference, another concept, just to make sure that you are passing me an associative container. So I actually provide you only the API that I want to support. Would we do that? Not always. Some would say probably, usually not. Should we do that? Yes, we should. Why? Because it will avoid bugs. Otherwise, we will have bugs. You send something that the other side should not use, it will be used. You open the fridge for the dog. Hiding small pointers and hierarchies, a new topic. Still, hiding information. But now I'm speaking about something else. Let's assume that I want to create a math expression calculator. So you can create a tree of expressions, in this case, a sum of exponents, 3 to the power of 2 plus minus 1. And there isn't any leak because eventually when I delete e, deleting E deletes the entire tree in a cascading way. So E deletes all its nodes. What is not so nice here? I don't like it. First, there is new and delete. I mean, no new and delete in modern C+ code. You should use, I don't know, smart pointers. And the other thing is that the calls to new and delete are not symmetric. I mean, you have 5 news and only 1 delete. I mean, it works. I designed that not to be a leak, but still something bothers me. And in any code review in the future, I will go on that again and check it again. I prefer first to have it a bit more symmetric. And you know what is the best number of symmetric calls to new and delete? 0, yes. So what do you say about that one? Is that a proper substitute? Let's go with that. Yeah. Smart pointers. No. I mean, yeah, maybe it's better than the previous one in a way, might be, but what bothers me here? It's too noisy, and it leaks implementation details, not memory. There isn't any memory leak, but the implementation details. What is the implementation detail that is being leaked, that is being exposed? That I'm using unique PTL. Maybe later on I will decide not to use unique PTL. By the way, how can I create the same thing, the same math expression tree without using unique PTL? In all different ways. Maybe I will be using static polymorphism. Yeah. So I would prefer going with something like that. Let's create a sum of x, of number, and eventually behind the scene there would be some kind of a factory, maybe a constructor, maybe I'll create here an R value, temporary R value that will be sent to the constructor, and then the make unique. Of course, this is better. The one above is better, I would say, than the lower one, which actually leaks information that you are using smart pointers, and the exact smart pointer that you are using. And the implementation would look like that. Binary expression, which is the expression that is being created, holds internally a unique PTL. This can be changed. And the constructor doesn't take unique PTL. The constructor takes something else and calls make unique. Now, somebody can say, oh, but then maybe there is a double allocation there, and then no, there isn't. There is some kind of an R value being moved. You can make it efficient. I have a talk on that. It was given in CppCon 2023. You can watch that on 6 ways of implementing math expression. And it ends with static polymorphism, where the exact same main, the one above, this one, the exact same one ends up with using templates and not unique PTRs without changing the main. And once you can change the internal implementation without changing the user code, it means that you did a good design. So hiding your implementation details includes hiding your hierarchies and the way that you handle the hierarchies. And when I say hiding hierarchies, then it goes to state pattern and strategy pattern. I mean, you are an employee. Maybe you are a subcontractor. Maybe you are an internal employee. Is it something that the program, the process, the user should know? I would say no. You are an employee. Go with a universal message. It's a very nice message. You are an employee. Why? Because if you are if you have hierarchy with employee, and then subcontractor, and then internal employee, you know that there is a trend, usually, that the subcontractor at a certain point becomes internal employee, right? If we like her or him, and you can become internal employee. You would like to do that? Yes, let's do the switch. And then if you worked with hierarchy that's being exposed to the program, then you come to this person and you say, but there is one small detail that you need to know. In order to make you an internal employee, we first need to kill you and then revive you. Are you sure? Yeah, this is how we do that. Usually it works. Now, it means many things, many bad things. First, we need to copy all the fields. One of the fields is the email. IT department says that you cannot copy the email because the old email is still being used, so we will get a new email with digit 2. Okay? What about my old emails? They are still accessible in the following month. It's a mess. It might be that you play in the soccer team of your company. You will not be found. They will be looking for the older pointer pointing to an employee that is not there anymore. Okay? So changing type in runtime is implementation detail. How can we avoid handling that? How can we hide it with state pattern? Employee is an employee. It just has a field. The field is which kind of employee. By the way, if the only difference is that I'm this kind of or the other kind, then it's just an enum. But if there is a different behavior, and usually there is some kind of different behavior, then it should be a state. I mean, what does it mean being a state? There would be a base class, employment type. And then you will inherit from it internal employee and subcontractor. And then employee, which would be the universal type, you just work with universal types, things that are not hierarchies. Much easier to work with. Same thing with the strategy. Why should I care with whether the pathfinder is BFS or DFS? I mean, why should I work with different pathfinder? I'm working with a pathfinder. Internally, there is a strategy that might be changed while I'm working. I don't care. I don't want to know about that. The code would be much easier to handle. Go with state pattern and strategy pattern. They are not just there in the Gang of 4 book. They are important. And then when you want to create the things, go with a factory method. I mean, why should I say what I need? Maybe I just need to pass the arguments, and then something would say, oh, this is what you need. But it would be easier. And again, it will push information details internally. So avoid exposing your hierarchies. Your process, your code, should work with universal things. Conveying less information on return values. Let's speak about this one. Foo, I return a vector of ints. Now, I do want to expose the fact that I return something that is random access. What can I do instead of that one? Returning an iterator is a problem because there is a begin and end. I can return a range, maybe, but the range is too generic because a range might be something which is not random access. Luckily for us, there is a range for random access. But I want even to narrow it a bit more because I know that this is in. By the way, what about this approach? I don't convey the actual return type. What do you say? It's too generic. The user would go to the function, see what the function returns, and assume that it is a vector, right? Because I didn't say anything. Saying nothing is not hiding information. Is asking the user, go to the header file, see what happens there, and assume. No, I don't want that. I want to say something. So I can say random access range of int. By the way, the language provides random access range. Stop. But if I want to say random access of something, it is a container with random access, and it holds integers, ints. So I created my own concept for that, relying on random access range and adding another requirement. Okay, can be done. Okay, so in a way, I'm saying something. Does it enforce the usage of you cannot do something which vector allows, but other random access containers would not? Like, for example, maybe you would call on the return value in placeback. Can you? Can the user get the return value and call on the return value and placeback, pushback? The answer is yes, it can.
Well,
they can.
Except you have a dangling reference now.
Oh.
You're returning a reference to a local.
No, I'm returning by value. I think that, I'm returning by value here.
Okay, no, you're right.
Thank you. Eventually, I'm returning the vector. It's essentially the same as returning outer, but saying something constraining this outer. And this vector can be used as the vector outside, but if somebody uses that as a vector and not as a random access range of integers, then I would say, you're assuming something that I didn't say on the API. Is it the best? No. Maybe there is something better. What can be better? A wrapper class. You want to actually enforce something? Add a wrapper class. By the way, here, testing would even be hard. If I want to test that the user doesn't use the return value in a way that I didn't plan for, can I do that? I want to make sure that the user of this function doesn't use the return value as a vector and not as a just random access range. Can I do that? No. I mean, you don't see all the users. And eventually, the function returns a vector. You can mock it, but then you will test the mock. You will not test the function, the user. No, you cannot test it. The user may deviate from what you intended. OK, but still, this is better than just saying a vector. By the way, the language does that. The ranges library is full of returning all kind of concepts saying, OK, you should assume that this is the return. So yeah, it is better than just saying a vector. Can we do it in a better way? But by the way, if it is a concept, then it means that I should implement that in the header or play with modules. It might be an interface. I can go with an interface. But then I should use dynamic virtual calls. It should be allocated, because if it is an interface, there is polymorphism. Then I cannot return it by value, because then there will be slicing. I don't want slicing. I want the actual thing. OK, so you should go with pointers. Oh, you should do dynamic allocation. Maybe I don't want to. OK, so you may go with a wrapper class. We just saw how to create a wrapper class. Should you? Yes, in some cases I should. When is the best? You know that you should do this thing. No, I should use a wrapper when a bug actually occurs. I mean, when you see, oh, we just catch the bug. This bug will reoccur. Let's change the API before it goes out to many other users and narrow it to be used correctly. Beware of leak abstractions. In some cases, the abstraction itself is conveying some behavior that you do not want to expose. You do not want the user to rely on something that is on the abstraction, like vector of Booleans. Proxies are problematic in all sorts of ways, so be quite careful about your abstractions. Hiding helper functions. What do you say about this thing? Let's assume that we have a thingy, and the thingy has a foo and a bar. But you should not call bar if you didn't call foo. Bar should always be called only after you called foo. What do you say about this API? I have a note. Would you read this note? I mean, usually we just use the autocomplete. I mean, the autocomplete allows me to call bar without seeing the document. Maybe it would be Doxygen or something that would go with it. No, somebody would call bar without calling foo. How can I enforce the contract, the API, the flow? You should not. How can I do that? Yeah, I can work with return values, so I will show two approaches. The first approach might be, if this is the case, you always want to call bar after foo. Oh, in some cases, this is the flow. It's not that if I want to call bar, I need to call foo. I call foo, and then I call bar. Is this your case? Yes. Oh, so why not do that? No, it's not the case. In some cases, I want to call foo, and I don't need to call bar. OK, so you may have a foo bar that gets a predicate and decides whether to also call bar. A bit complicated, but doable. That's fine. Another approach might be, let's create a foo that returns a token. The token is created inside as a struct called bar callable. The bar callable is something that can actually call bar. You cannot call bar without calling foo, because there isn't anything that exposes the function bar, except for the return value that is returned from foo. So the return value allows you, if you want, to chain the call to bar. So you can call foo and then bar, or you can just call foo if you don't want to call bar. But you cannot call bar if you don't have the token returned from foo. So I'm enforcing something that you will not do your own flow that is not supported. API should be hard to misuse. What about using protected? What do you say about this one? The parent has a protected member called wallet. And the child has endless celebration using wallet. What do you say? I would say no. I mean, protect the members, why shouldn't you use it as a private member? And then you would have a function, need money, with a proper signature, getting a long double, returning short. And then the child can use the function. It's a bit misleading, because parent and child in the real world are two different entities. And here, with classes, the derived class is the base class. They are the same entity. So it's a bit misleading, this metaphor. But I would still say that I do want the base class to manage its own fields, and I don't want to allow the derived class to interfere, to directly access the fields being managed by the base class. This is a very basic approach of encapsulation. Go with the encapsulation. Hide the parent's wallet. You can still provide a function, and the function should be in the protected, by the way. So strongly prefer data members to be private. Don't go with protected. Usually, it's wrong. Prefer protected member functions over public if possible. By the way, of course, if the member function can be private, it should be private. But if you need to expose it to the derived class, put it in the protected. No, not in the public if it is not needed outside. Testing private behavior. I will skip these slides. I will just say a few words. It was mentioned in the API for testing talk by Bloomberg. There are approaches how to do that, but be very careful with testing private behavior. Usually, you should test the public behavior. Once you feel that, oh, I need to test something internally, I would split it to two different things. Changing, mutating, never do that. Mutating private thing from the outside creates a test which does not relate to the real world. There is something that you create code coverage in a way that is not the actual way that would run in production. So you are testing something which is not real. So mutating private things would probably be wrong. On the other hand, if you need to get information on something, like on the state or on the strategy, I'm quite OK with that. I mean, yeah, we may have a protected function or a private function, and then a way to access that with a friend in order to get some information about what was the state when I did that. So should I check private things on the class in the test? You should usually avoid, unless, OK, I do need to check something. OK, if there is a reason, do that. But never mutate private things. Usually, it means that something is wrong in your test. So there are a few slides saying what I actually said, and also pointing to testability and API design by Bloomberg. Given yesterday, you should look for the video. Use the proper context for your code. Namespaces. Put things in proper namespace. Hiding things in namespace. Detail namespace, which means, oh, this is internal. I mean, you can access it, but you say that you access something in the something colon detail. I shouldn't. You can use anonymous namespace, unnamed namespaces. Modules. Modules assist in information hiding. There is a talk about that in CppNorth. You just missed that. It was in the other room now. But you would be able to watch the video. OK? It is a tool for hiding your implementation details. Last item, I owe you something. Do you remember what I owe you? Yeah, that was good. Yeah, it requires only memory of 1, not of 7 even. So yeah, it was make unique. Do you remember make unique technical issue? Let's solve that. So private token idiom, also known as access token pattern, passkey pattern, whatever. There are many different names for that. Eventually, I want to allow call for foo constructor for make unique. I don't want to provide foo function outside, because foo is, in a way, something that I don't want the user to use. I want the user to go through the factory, OK, through the create function. But technically, there isn't a nice way, there isn't a feasible, good way to move the constructor to the private. So the solution is to create an internal class, let's call it a private token in the private. The constructor would take a private token object as an argument. The only one that can provide this argument is this class or anyone who is a friend of this class. Solved, problem solved. Now, the constructor is now in the public. I didn't have any other choice. Make unique needs to see the constructor, and you cannot friend a function to make unique. It doesn't work because make unique is templated. I think this is the reason. But you can still friend the a private token because it's not make unique that needs a private token. It's the constructor. It's the call inside. It's a function. It's the factory method itself, not make unique. So either the factory method is internal, in this case, oh, the factory method just sees that, or the factory method is outside, and I friend the function. I give it the privileges to access the private token. I will take the questions at the end because we are quite short in time, but we'll have, I guess, a few minutes for questions. So in a way, this should solve the issue. The constructor is still in the public, but is not usable for external usage. You want to create an object, go with the create function. I want the API to be used as planned. Let's summarize. Hiding your implementation data is more than just a design recommendation. It actually avoids bugs. It creates your code more robust and maintainable. Encapsulation, decoupling, we discussed that. You know that you want that. Now the question is, what do you do to achieve that? Having private fields is not enough. It is context specific. So you need to accommodate the proper context. Some context may need these functions. Another context may need these other functions. Okay? Use interfaces. Use wrapper classes. Maybe you can say something with concept, but you should bear in mind that concept doesn't enforce the usage. Keep abstractions. The extra. Being abstract is something profoundly different from being vague. The purpose of abstraction is not be vague, but to create a new semantic level in which one can be absolutely precise. And I remembered seeing this citation in another talk from CppNorth, so I went to look for that, and eventually I found that. It was banned in last year. Exact same phrase from the extra. In his talk. It's a keynote from CppNorth 2023. You should go and see it. Very good one. And almost last one. You may have reasons why to avoid hiding your implementation details. In most cases, they are wrong. Look for things that shouldn't be exposed and improve your code. Any questions? Yes? There is a mic. Let's wait for the mic for a moment.
Why did you insist on make unique? In your case, it's an implementation issue. Make unique doesn't actually do anything interesting. You could have just constructed unique pointer from a raw pointer, and then you wouldn't need the private token. You could just declare the factory friend and make the constructor private, and everything compiles just fine.
So there was a comment saying that in this specific example, instead of using make unique, I could have created a raw pointer using new. And then I have access to the constructor, even if it is in the private, if I friend it. Yeah, it is doable. Usually, I do prefer make unique. There are reasons for that. I don't want to see new and delete in my code. But it may go with other cases. Maybe it is a make shared that I prefer. So bottom line, in cases, you can argue whether this is the case or not. There would be cases where something must be exposed. It's in the public. And you still don't want it to be used outside. How can you do that? With a private token. If there are no other questions, I do have an additional slide reminding all that. C++, I'm one of the organizers of a Core C++ conference in Tel Aviv. This year it will happen in November. And if you think about coming to visit, we'll be very happy. Submit a talk. If you need assistance in covering your travel, usually we can do that for accepted speakers. You can either talk to me or go directly to this link. Again, thank you very much all. Thanks.